Here we're still on the 3-3 section, and yes, at the end here, remember approximately halfway between, and yeah, it was pointed out that I'm talking about points of inflection. This could have also been another turning point, right? Because there's up to 3 turning points. So yes, it could have been a turning point, a full turning point happening there, or on the right side, it could have been over here. We don't know what's happening. We just know that there's only one root. Right, so it can't fall below it, but there could possibly have been 2 more turning points, because if this has a degree of 1, 2, 3, 4, there's maximum you can get 3 turning points out of that. So there could have been turning points or points of inflection up there. We don't know, right? So there could have been up here on the right or up here on the left. We just know that there's only one possible route that it was going through, so it can only touch the x-axis once. But up here, it could have been 2 more turning points or points of inflection happening. Okay, so that's the vague part where you feel like you shouldn't be drawing it looking like a parabola, but that's the only information you have, right? So again, this is the stuff where a little bit more detail will give us more information to fix the graph, and that's the part where I said it makes you feel a little bit vague when you're drawing it. You feel like you're missing something a little, okay? And that's why you do feel that way. Okay, we have this part. When you're doing your homework, make sure you look at the scale, because some of the scales are highly exaggerated or shrunken very much. And then we're now on to the cubic. So we're looking at cubic on this page, a lot of them. And I'm introducing you to a little bit of the factoring. Okay, so we will learn how to factor longer polynomials, but for now we have our factoring skills from before, grade 10 and 11. Okay, we are going to look at how to factor polynomials that we haven't been able to factor before. But for now, don't forget what we already know how to factor. So this one is already factored for me. I can see that this one has an order, right? The order is 1, and this one here has an order 3. Okay, an order of 3, order 1, order 3. So then, when I'm finding my roots, I can remember that this one is going to be different looking than this one in terms of roots. I have my bubble over here, so let's just go. We can say x-intercept, roots, or zeros. I think we were using x-intercept. Okay, you can use any of those words. For this one, it'll be 0, and for the second one, it'll be 2. Okay. Then I have over here, in this bubble of knowledge, if the factor is cubed, right? So if the factor is cubed, in other words, order 3, so if the factor has an order of 3, then the corresponding x-intercepts are points where the tangent is where the x-axis is tangent to the curve, which means touches once, right? So once, so it touches once, and passes through the x-axis, and the graph has a cubic shape near that x-intercept. So it passes through once, that says once, O-N-C-E, one time. Sorry, I know that looks funny. I now realize O-N-C-E, once, one time. Okay, passes through one time. That's what means tangent. So passes one time. It goes through the x-axis, and it has a cubic shape. So those are all bunches of information. Now, the part that they forgot to do was you haven't been introduced to the cubic shaped function. So again, this is a throwback because it used to be introduced a bit earlier. So let me show you what the cubic function looks like in general. So the cubic function is this, the very base parent function. The parent cubic function looks like that. If you're thinking about making a t-chart and plotting points, that would tell you that at 0, it's 0, at 1, it's 1, and at 2, it's 2 times 2 times 2, 8. So it goes really high up, and it looks like this. So basically, it kind of looks parabolic there, but maybe a little faster, right? A touch faster. Then on this side, at -1, it'd be -1, and -2 be -8, and it looks like it's split this way. So it concave up this way and concave down this way, and that's the cubic function. Okay, and we will be studying that in the next section in 3.4. Transformations of cubic and quadratic. They just forgot that they didn't introduce you to what the cubic function looks like. So they said it has a cubic shape, but that's what the cubic shape is. So it goes from one concavity to another concavity. So it kind of looks like that parabola has been split in half. I always feel like the second part of the parabola has been split in half, and a little bit faster, so vertically stretched. Okay, so it has that shape, and you can see the x-axis is tangent, which means it passes through one time, and it passes through. It actually goes through as a tangent line instead of touching and bouncing off. So they're saying it tangents through it. So that's what all these words are saying. It tangents, but it goes through it to tangent, not touching on the side of it. Okay, so that's what the shape should look like instead of the squared and the linear. So when we get an order 3, we're going to try to draw that shape at the order 3 root. Okay, I'm going to show you that in a second. What else do I know in order to graph it? On the side here, okay, on the side, I'm going to do, I like to write down, remember, LC is just my short form, right? If you're going to actually answer a question, write leading coefficient. But for me, LC is 3, look at, you need order, and you need the x's. I have 3 positive x's, so it'll be positive, times another positive x, so it's going to be positive. The degree, I have 3 x's, so 3 and 1 more, so degree of 4, so that means it's even. And that means it's like a parabolic idea, which means it's up at the 2 and 1. That gives me my end behavior. So it's at the 2 and at the 1, so my end behavior. I know I draw this part small, but it's 2 and 1. Yep?
Wait, why is the leading coefficient positive?
3 positive x's, so positive, 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 times another positive, yeah. Okay. All right. What else do I have? We introduced yesterday that we should go back and always do the y-intercept. Right, so y-intercept is when x equals 0, so y equals 0 times negative 2. I don't even need the second part. As soon as I see that one of the factors is 0, I know y equals 0. Okay, and just a little graph. Remember, these are just sketches, not precisely perfect, but we're just putting down the information we have. So we know it's at 0, and we know it's at 2. All right, so now we're going to pass through this one, and we know that the end behaviors are at 2 and 1. Right, so end behaviors, I just remember I start in this quadrant, I go through, and I end in this quadrant. I erase those after, and I'm just telling myself my end behaviors. So now, we're going to pass through. This one has an order 0. This one is order 3. This one, at 0, it's an order 1. Sorry, I think I said order 0. Order 1. So it passes through completely, just goes right through. This one has an order 3. I want it to be cubic. So it's not a turning point. So it doesn't hit it and bounce away. It actually is going to look cubic. It's going to look like that at that point. It's always really hard to draw this. And again, you hate it when I say this, I'm probably sure, but the part that's missing is in calculus will tell you exactly where it starts to curve one way versus the other. Because you're like, I feel like I don't know when to start the other part of the wiggle. That's the concavity. So what you're thinking in your head is like, I feel like I don't know how to turn the concavity. That's the point that we're missing. Okay, and that's why we're trying to do it as best as we can. The little part that you always feel like I'm missing it, it's a little messier than I want, is the part that we'll figure out later on. Okay, but we can still draw a pretty good graph. So we're going to go through it. I'm going to try to draw it in marker. Oh, please. I hope I don't mess up. So it'll be like this. So through, turn around, twist, like that. So this is where, see, I'm trying to do concave up and concave down and then make it turn around. So this is the part where I want that to look cubic. Okay, so concave up to concave down. Some people say, can I do concave down that way? But then it makes it look like a square root function, which kind of looks funny, right? That isn't the idea we're looking at, so we're trying to make it look cubic like this. Okay, and that's why I was saying in the other section that I don't want you trying to wiggle. If you miss a point and you wiggle your graph a little, it's going to make it look cubic in the wrong spots. So you want to try to make this for sure smooth through. If I circle it and go looks cubic, that means you wiggled when you went through it. And again, the wiggles are points of inflection, and you can't add extra points. So it should go fully through, and this is the only part that looks cubic, and you can erase these little bits so it's not distracting. Okay, Okay, just don't introduce too many more points of inflection, so no more extra ones, and don't make it look like it's straight, right? I know it's a little hard to draw. All right, let's try again. Any questions with that one, all right? Try it again. This time, I'm giving you a bit of factoring to add to it. Again, we're only doing the factoring that we know how at this point. So yes, we know how to do common factor, right? So if you look at that and go, that's not in factored form, yes, you will have to introduce that. So I'm going to go negative x cubed x squared minus 2. Okay. So then we're going to get your roots out of this, or x-intercepts or zeros, right? Any of those words mean the same thing. So x-intercepts will be at, for this factor, 0. And for this factor, let's pull that aside, x squared minus 2 equals 0. So x squared equals 2. What's x equal? What's x equal? One more time. X equals more?
Plus minus.
There you go. X equals plus minus root 2, okay? I want you never, ever, ever to forget when you have an even exponent here and you take the root of it, 4th root, 2nd root, 6th root, you need a plus minus. Not for the odds. We never, never, never want to lose that again. You will lose a mark. When you lose one of the roots, you're going to start to lose a full mark now, right? Before we were nicer, I think sometimes we would maybe take off half. How awfully generous of us. Now I'm going to take off 1. You cannot be dropping that anymore, okay? You've got to recognize when it's squared and you square root, you're going to get a plus minus. Otherwise, half your graph is going to be missing. You mean like, this is the weird thing. It's actually going to be so hard to draw it if you drop that, because what happens is that, look, you try to draw it. I'll just draw a little one over here. It's not too big. And here I'm just going to put an arrow because cubic shape was over there. Okay, so that was me showing the cubic shape up there. Okay, here. If you dropped one of the roots, you will only have the x-intercept at 0, but this should be plus and minus root 2. You don't have to show me that work. You can if you want. Some people go, I can do it in my head. Only if you do it in your head accurately. So don't do steps if you need them. And then I put the roots there. So you would only have one of the 2 roots. Trying to draw this without one root, you're going to go, this is impossible. I can't make it churn the right way. Like I feel there's something missing, and that's why it should be screaming at you that you're missing something. So you will not be dropping your 2nd root. So this side, right? Half your graph is going to be not accurate, and it's not going to churn the right way. You're going to be like, this doesn't work, right? And it's going to be very frustrating for good reason, because you're missing a root. Okay, so here, let's do the rest of it, and we'll try to graph it in a minute. What I want you to remember, though, this one is order 3, right? These are both order, what? 1. They are each one of the 2 roots. So each one of these is one of the 2 roots. So I know it's squared here, and you're like, is it order 2? Not the whole thing was squared. And we broke that up into 2 separate roots. So that's one of them, and that's the other. I didn't double up. Order 2 means I had 2 of the same root. So if I got root 2 twice, and they were both positive root 2, then yes, it's order 2. Here, it's still order 1, order 1. I had 1 of each, and I had 3 of the 0. Think of the factors. I had 3 of this one and 1 of each of those. Okay, so order 1, order 1, order 3 in the middle. All right, so be careful of that. People think it's squared here. No, but each root separated out. So you had 1 of each. Okay, so is that okay how you read that? Because I know it's squared here. This is a trickier one, squared here, but it's because I broke it into the 2 roots. So each one is one of them. They're not squared. This one's order 3, so that'll be order 3, cubic shape, linear, linear. Okay, let's do my leading coefficients and all that stuff. So my leading coefficient for this one is, now you can look at the original form before you factored it. I can see right away the expanded form is very useful. It's negative. And what is my degree? Well, my expanded form is also very useful. It's already 5. I don't even have to look here. So I know it's 5, which is odd, which means it heads down. So that gives you your end behavior. So it starts here in this quadrant, right? And it ends in this quadrant. So my end behaviors are up here and down here. These two are linear. Does that make sense why they're linear? Right? So I know it's squared here, but it's not two of the same factor. It's one each. Right? So 1 for each. That squared stands for one of these each. That's 3, so that'll be the cubic shape. Okay, so linear, linear, cubic in the middle. Okay, so here's when you draw it and you're like, oh, I feel like I'm missing something. It's always just that wiggle, right? The point of inflection makes you feel a little bit iffy, but we can do it. So we're going to head through it, starting in the upper corner for my end behavior. We're going to go like this. Oh, I always hate doing this because I do it with marker, so when I make a mistake, it looks really, really bad. So go through, twist, and through. So you're doing cubic shape. I wish I'd done that a little bit better, but that's okay. So you guys can see cubic up, cubic down, like that. And then you can go ahead and erase my end behaviors. Be a little better. I can't. Erase that. Okay, so you're trying to do a cubic shape there. There, that feels a little bit better. Got too wide. There's my zeros there. All right? Yeah.
At the ends of this graph, would there be like the bottom of the curve like there was last time?
At the ends of the graph?
Yeah.
No. So here, this is already, when you have a cubic here, that already takes away 3 degrees. So that takes away 3 degrees. That takes away 2, so you already have 5. So there should not be anything else happening, because then that would imply that it's higher than a 5. The very most, you got a power of 5 here. That takes the cubic characteristic away, and this takes the 2 linear, so there should not be anything else happening on the ends, yeah. Okay, because that already covers all of it. 3 and 2, so no more. So don't put anything else. So that's why. So don't add anything else unless you're sure it should be there, because if you did another cubic there, I'll be like, you can't. You already took the cubic from here, 2 linears, that's your power of 5. All right? Okay. 2 more. What I do here, I got a little bit of some stuff kind of mixed up. I don't even know what shapes we have here, so let's take a look. I just tried to mix it up. So there might be some order 2s, order 1s, order 3s. I don't know. Let's see. But what I did do, what else do we have to do? So I don't know if we need to star anything. The only thing here was that we now have to factor, okay? But we also want to factor here. So what I want to highlight here is that we can still factor fully. Okay? Factoring fully is what we always want to do, like that. Okay? Factor fully. Make sure everything's fully factored. This is not fully factored. So when you saw that, you should have been like, oh, wait, that is a difference of squares. I should go more. Here, when you saw that, you should have been like, but there's a 3 in there. That also is a different, this is not fully factored. So it looks factored, but you always look to see what you're given to see if you can fully factor. We want it to be fully factored and gather up your factors. What I also don't like is that I've got things kind of mixed up here, but that's okay. I can handle that. So I can still solve that one. This one feels weird because I've got the x second, not first. You can always change the order if you want, but I'm okay. Okay, so let's try it the way it is. We've got backwards and forwards orders. That makes it feel weird a little, but we're going to look at our factors at the end and make sure we compare them properly. So when you compare them, you want to make sure you're comparing them the same way. Okay, so let's factor first and then look to see what we have. So for this first step here, x we can't factor anymore. Can we factor 3 minus x squared anymore? No. Right, so I'll leave that one alone. But this one I can factor. It's x minus 3, x plus 3. Okay, so then that's fully factored. That gives me, again, linear, linear, linear. When I solve this, okay, so let's grab this, and we're going to solve this one. 3 minus x squared equals 0, and this is 3 equals x squared. And then x equals Oh, plus minus, and if you don't say the plus minus, that is awful, right? We just talked about that. Yes, sir.
For x squared minus 9, can you also put it in like unfactored form and still do the exact
Yes,
same
you
thing?
can.
It would still be plus minus root 9.
Exactly. Very good. See? So this is what I was going to show you. See how they're both squared. You end up with two roots. So that's what I was saying up here is that this always feels funny. Is like, how do you know? This is this case. So I know I get two roots because of this. You actually get two roots here. So if you didn't want to show this step, yep, you can go straight ahead and just say plus minus 3. Right? You're still getting your two roots out of that, and it's a plus minus 3. You don't have to show it fully factored as long as you know that this can give you two more factors. So if you want to skip that step and go to your roots,